Assalamualaikum warahmatullahi wabarakatuh. My name is Manu Sabina binti Bahazuddin, and today we will like to continue our group presentation by designing the circuit and do the simulations of our system, which is the smart street light system using Proteus. So in this video, I will show the part of connections of LDR and LED with Arduino. So let's continue with the circuit. First, the circuit will the component that used in the circuit is Arduino Uno, where it will act as the microcontroller to the system, and we also use the sensor, which is the LDR sensor, where it used to detect the intensity of light. The sensor will be connected with the 10k ohm resistor, and we also have the LED, where the LED will be represent as the street light. The LED will be connected with the 1k ohm resistor. So in these simulations, we will use 3 resistor and 3 LED. As for the LDR connections, the input of LDR will be connected with the DC supply, and the LDR and the resistor will be connected to the Arduino pin A0. As for the LED one will be connected with the pin 13 Arduino. As for the LED 2 will be connected with the pin 12, and as for the third LED will be connected with the pin 11. As for the output LED and the output of LDR will be connected with the ground. So as we can see here, this is the connections of the LDR to the Arduino and the LED connections to the Arduino. As for the part of PIR sensor connections and the simulations will be continued by my friend Farid Haikal in the next video. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farid Haikal bin Zalan, and I will continue to finish the construction for smart lamp here. And then first we add the PIR sensor. Just start the PIR and then click here. We have the analog and digital. Here is digital, and then this is the analog, but we choose digital. Then press OK, and then we click here, and then for the G is ground, then we connect with ground here. And then for the output here, we connect at the pin number 9 at the Arduino. And then for voltage, we choose here for the terminal power, and then we connect at the V here for voltage, and then we type 5 volt here. And then we also insert the virtual terminal here, and then for RxD connect at the pin number 1, and then for pin number 0 we connect at the DXD. Okay, now we finish construct the design Arduino for smart lamp here, and then we go to the coding. Okay, first coding here, this is integration to define the number of input at the Arduino here. Okay, for example, LED number 1 here, we connect at the pin number 13 here, then we describe it here. Then LED2 pin number 12, LED3 at the pin number 11, and PIR pin at the 9. You can see 9 here. Then here we state PIR state for initial, we describe is low, and the value is 0. And then next we go to the void setup. Void setup is which is we declare the pin is output or input. Okay, for example, for LED pin, for all LED, the output, this void setup is output. And then for the PIR pin is input. And then this is serial begin, which is if we use here serial monitor. If you connect with the hardware, we can use the serial monitor. By the way, if we use a Proteus, we must use the virtual terminal here. Okay. And then void loop is our main coding. Okay, first int sensor value analog rate is 0. This is for LDR here, which is the LDR. We must use the analog input. And then value equal to digital read, which is we describe here. We use the digital, which is 0 or 1, the binary number. And then serial print LDR value is, and then serial print sensor value for LDR here will show in the virtual terminal here. And then it will appear after 1 second, or by the refresh rate is after 1 second. And then we go to the next here. Okay, if sensor value is below than 100 and the value is high or 1, so the all LED will on or high here. Then other else after 1 second, this is 1 second, all LED is off. But after 1 second, LED pin 1 will off first, and then after 1 second more, LED number 2 will off, and then after 1 second more, LED number 3 is off. That's all from the coding. Okay, to insert, I forget to insert the logic state here. Then we go here, P, and then type the logic state. Okay, then press, and then we can rotate it. Okay, and then connect. Okay, we have 1 or 0, which is 0 is low and then 1 is high. Okay. Okay, basically in this here we have the program file. We must select the hex here. First we find back where I put the this is okay. We must put the hex file for PIR sensor. If not, we can run the simulation. And then okay, for input the file here, we must verify the coding here. After finish, we take the location of hex file, this smart LED coding. Okay, finish. So we go to the find the hex file here. Okay, this we copy it, the hex file. After we verify, press Ctrl C and then go here and then put here at the program file. Then we press OK, and then after that we can run it. Okay, after we run, you can see the virtual terminal here will appear. Okay, now the LDR value is 0, and then if we so basically the LDR is below than 100. So then after we press the motion sensor is high, then the LED lamp must be on. But in this Proteus, the simulation is a little bit slow, so we must wait a second here. You can see here, this is the design for smart lamp. We have 3 LED, 1 PIR sensor, virtual terminal. This is a virtual terminal. After we run, one Arduino no, and then we have LDR resistor. You can see the update 10 because here is no light. If have the light at here, detect light, then the value is increased. Right now you can see all the LED is on because at the coding we must this LDR is below than 100 and this motion sensor is high. Okay, that's all from me. My friend will continue to explain about the output voltage and current at the input and the output load here. Okay, thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Anura Shura binti Muhammad Nur Zaki and my metric number is AE180085. So I'm going to present my part, which is the result of output voltage and current for the load. As you can see, the left side figure show the load when is off and the right side figure is when load is on. So when the load is on, there is 4 type of condition, which is the first one is when the status of the motion is low and LDR value is less than 100, the reading of voltage across load at resistance and LED becomes 0 volt. So the voltage and current across resistance and LED both are 0 volt and 0 ampere respectively. And then for the second condition, when the status of the motion is high and LDR value less than 100, the reading of voltage across resistance is 0.10 millivolt and 5 volt. Then the voltage and current across at the resistance and LED is 5 volt and current 0.06 microampere. The third condition is when the status of the motion is high and LDR value more than 100, the reading of voltage across at resistance and LED becomes 0 volt. So the voltage and current across the resistance and LED both are 0 volt and 0 ampere respectively. Same goes to the fourth condition. When the status of the motion is low and LDR value is more than 100, the reading of voltage across load and LED becomes 0. So the voltage and current across the resistance and LED both are 0 and 0 volt and 0 ampere respectively. Therefore, we can conclude that other than status of the motion being high and LDR value less than 100, no reading will be shown on the instrument, in the measuring instrument. Okay, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nurisha Danti Musa. My metric number is AE180105. So this is our overall loop for smart street lighting simulation. This simulation is run in Proteus software. So for the first condition, as you can see, the output is light off because of the input. Both of the input is not meet the requirement, which is the requirement is the LDR should be less than 100 and the PIR should be in high position. For LDR sensor, it is already meet the requirement, but not for PIR. Okay, as you can see, the LDR value is 10, so it is less than 100. Okay, for PIR it is in low condition, so only one requirement have been fulfilled in this system. So but still the light is not turned on because of it not complete the full requirement. Okay, for the second picture, the value of LDR is also less than 100. Okay, first requirement is fulfilled, and for the LDR, for the PIR, the value is high. Okay, the second requirement is fulfilled, so the light will be turned on in this part. Okay, so this is the example of value that fulfill the requirement to lighten up the light. Okay, for the next slide. Okay, so this is the condition for LDR1. Okay, laser, the value of LDR1 will be influenced to the light LDR to sense the light. Okay, the laser, the value, the decrease of light that it will detect. Okay, as you can see, the value of LDR is increased and it will detect light. Okay, but still it is not more than 100, so it will be in this state it will be fulfill the requirement, which is the first requirement is LDR must be less than 100 to make the light is on. Okay, for the second, okay, the value is still increasing but still below than 100. So even though the light is the LDR detect that the light is increasing, but at this condition our smart street lighting will be still turned on. Okay, as long as it meet the both requirement for LDR and also PIR. Okay, and then for the last value, which is 512, we know that it is more than 100, so this is confirmed that our smart street lighting will be not turned on because our first requirement, which is LDR should be less than 100, is not fulfilled. Okay, and also same goes with the value of 975. The increasing the value of LDR value will affect it to the performance of our smart street lighting. Okay, so this is the condition for input for PIR sensor. Okay, which is 0 represent as low condition, 1 represent as high condition. Okay, as we know that 0 is if we put the value of input for PIR sensor is 0, so the light is confirmed will not be turned on because it doesn't meet the requirement of the smart street lighting to be turned on. Okay, for the second picture, it shows the value of 1, which is high. Okay, it is meet the requirement. So in this condition, there are a chance to the light to be turned on if the LDR is also less than 100. So I think that's all for me. Thank you.